Hello. Today I am self-hosting SimpleX, a privacy-oriented messaging app with tons of smart and useful features. SimpleX is available for Android, iOS, Windows, Mac, and Linux. This is not a guide about the app itself, but a tutorial about hosting your own SimpleX relays on a VPS. So if you don't know about SimpleX, or even if you do, be sure to visit their documentation website to learn about how it works, and about amazing privacy features that you might have missed. If you're confused about something, please check the links in the description section below, where I cover in greater detail almost all the individual technical issues necessary to complete this guide. Let's begin. Let's start at SimpleX's GitHub. Here's the link to their website. And here you have all the documentation, including much of what I'm going to do in this tutorial. The first pinned repository includes the client releases for all the platforms and operating systems that I mentioned in the introduction, with their digital checksums. The second pinned repository hosts the code for the SimpleX components that we need, mainly the SMP Server, used to pass messages in SimpleX network, and the XFTP Server, for file transfer. There are compiled executable binaries available for both of these, but only for Ubuntu, version 20.04. Since I am running Debian 12, I will have to build my own binaries from the source code. I have already set up my VPS with Linux Debian 12. Let me give you a quick overview about how I have set up my server. And please remember to check the links below if you need specific detailed information. My administrative user is called SimpleX. SSH by password authentication is disabled, and only the SimpleX user can SSH in. No other user can log into the server by any means whatsoever. The only process that listens on any external ports is SSH. A firewall prevents all incoming connections except for SSH. A fail-to-ban jail protects SSH from brute force attacks. This is my external IP. These 4 domain names have type A DNS records pointing to it. And my system is up to date. Okay. To build the binaries from source, I will follow the instructions under this section, using your distribution. But look at this, my VPS has only 1 GB of RAM. And although this is just fine for running SimpleX relays, I wouldn't advise you to compile software in such a machine. It could take several hours, or not work at all. For this purpose, I have set up a Debian 12 virtual machine in my host computer. I've assigned to it 8 gigs of RAM, so everything should be okay. When it's finished compiling, I will copy the binaries to the VPS through SSH. So the first step is to install Haskell. Follow the links. Installation. Debian 12. Install these packages. Run this command as a non-root user. Choose all the default options by pressing Enter. Source: the bashrc file. It is very important that you install this specific version of GHC. If you go with the latest release, the build might fail. So ignore that warning. Set the currently active GHC version. Do the same for Cabal. And we are ready to build. The latest release is version 5.5.0. Told you, binaries for Ubuntu only. I've noticed a pre-release version 5.5.1, so I'll probably check out to it. So I will clone the repository into my computer. First remember to install the command git. Verifying digital signature. I'm missing the signing key, which belongs to the main SimpleX developer. I'll get it from his GitHub page. Just type .gpg after his username, copy it, and the following command will fetch it and import it into your GPG keyring. Try again. Good signature. Checking out to version 5.5.1. And finally, make sure you have these packages installed. Please pay attention. You also need to install this package. Otherwise you will get an error when building. To build the SimpleX binaries, type cabal install. And be patient. This might take close to an hour. When it's finished, you will find links to the binaries at cabal bin. Now I will move these two binaries to my VPS through SSH. And store them at user local bin. First let's set up the SMP server. I will create a user for the SMP process that cannot access interactive shells. Create the following directories and make the user SMP their owner. It's time to initialize the server. Asking for help will show the available options. First of all, notice that the user SMP is the one running the command. I will enable logs, and specify my fully qualified domain name with the subname, SMP. Accept the defaults by pressing Enter. Here's my server's address. Allow incoming connections on port 5223. I am going to run the SMP server as a service. You will find the following service file in the SimpleX documentation. Please make sure that you placed the binary file at user local bin. Reload System D, Manager Configuration. Start and enable the service. The server is running. You can follow the logs with the command, journal control. A new process is listening on port 5223. Now let's move on to the XFTP server. Create a user. Create the following directories. Change their ownership. These are the options when initializing the XFTP server. Make sure that the user XFTP is the one doing this. Enable logs. Fully qualified domain name with XFTP subname. path for file storage, and file storage quota. My VPS is 25 GB, so 10 GB is about right for me. Here's my XFTP server's address. Allow incoming connections on port 443. Let's create a service for the XFTP server. Okay. Pay attention. This is the service file that you will find in the SimpleX documentation. But there's an error. You need to fix it, or the service won't start. Go to the end of the exex.post directive, and edit the date format. Add an additional %sign in front of each interpreted sequence. Reload Systemd Manager configuration. Start and enable the service. The server is running. You can follow the logs with the command, journal control. Great! My server should be able to relay messages and files in the SimpleX network. So let's test it. For the sake of convenience, I am going to do it from desktop. You can use the mobile app, if you want. Verifying checksum. I have to make the file executable. Again, this is not a video about the SimpleX app. Learn it. It's really good. I will add my servers in Settings, Network and Servers, SMP Servers, Add Server. Test server. My SMP server is working. Save servers. XFTP servers. Add server. Test server. My XFTP server is working. Save servers. I am going to send an invite link to a friend with whom I can chat and share some files. I can easily test my SMP and XFTP servers by disabling all the relays that come pre-configured by default. I am sending a picture of this QR code to my peer. It works. I am receiving messages and files from the SimpleX network, exclusively through my server. This doesn't mean that you should do it this way. You can choose different combinations of relays for different contacts. Again, take a look at SimpleX documentation. Okay. What happens if I want to make an audio or video call? For this use case, the SimpleX defaults are not so great. I would be disclosing my IP address as well as metadata about the call. I will fix that by setting up my own WebRTC ICE server. The first thing I need to do is to get an SSL digital certificate, issued by a certificate authority. I will get one for free, from Let's Encrypt. Install the following package. And allow incoming connections on port 80. I want to obtain a certificate for these two domains. And I don't want them installed in any server software. I just want the files. Here's where my certificate and private key are stored. Remember that. Now I need to install a turn server that will relay WebRTC communications between two peers. Install CoTurn from the Debian sources. And uncomment this option to enable it. Let's edit its configuration file. There are 16 lines that you have to add. I will use the search function in the editor to locate them, so I can edit them. Please take a minute to read the commented lines so you roughly know what's going on. I will generate a random password for my user, SimpleX. Specify the paths to your SSL certificate and private key. You need to find out the name of the Linux user group which will be running the CoTurn service. Turn server. Just another random password. Save and exit. The last step before bringing the server up, is making sure that the path to your certificates, is readable by the CoTurn process, user group. I will allow the members of the group turn server to access the Let's Encrypt directory. The relevant directories are, Archive, and Live. This is the subdirectory that contains the files. I will make the private key readable by members of Turn server. Let's check. Great! Now I can start and enable the turn server. Looks good. Finally, add the following firewall rules. We're finished. These are the firewall rules of my server. I need to add the addresses for my stun server and turn server, one per line. And for the turn server, I need to know the username and password that I defined in the co-turn configuration file. Although our cameras are covered, you can see that both feeds work correctly. One last thing. Your SSL certificate is good only for 3 months. But Certbot probably added a cron task to your system that will try regularly to renew them automatically. As long as you keep port 80 open, this will get you the certificate all right. But it might mess the permissions of the files, so that they're no longer readable by turn server. To fix this, I will create a cron task of my own that will execute a script daily. This will take care of the issue. But you can also delete the certbot cron job and run the certificate renewal yourself. Like this. You could also redo the directory's permissions, just in case. Don't forget to make your script executable. To upgrade SimpleX, build the new binaries from source. SSH them into your server. Stop the SMP and XFTP services. Replace the old binaries with the new ones. And restart the SMP and XFTP services. Bye bye.